We're going to continue our work with probability by learning about theoretical probability. Theoretical probability is the probability or the likelihood that an event occurs when all of the outcomes of the experiments are equally likely. We remember from yesterday that probability can be written as a fraction, decimal, or percent. So, like we said yesterday, the probability of an event is equal to the number of ways the event can occur divided by the total number of equally likely outcomes. Let's look at some examples. Example 1 says you roll a standard number cube one time. We want to find the probability of each event and we want to write our answer as a fraction in simplest form. So part A says the probability of a 5. When I think of a number cube, I know that there is one 5 on a number cube. So there is one 5 out of 6 total sides on a number cube. So the probability here is 1/6. If I think about that in likelihood terms, I know that 1/6 is 0.16 repeating or 16.6 repeating percent. So this would be an event that is unlikely to happen. B says the probability of a 1 or a 6. When we see this word or, this is talking about what we call a mutually exclusive event. When we have a mutually exclusive event, that means that one event or the other would be an acceptable outcome. So if I'm looking for rolling either a 1 or a 6, then both would be acceptable. So there is one 1 on a number cube and one 6 on a number cube. So in total, there are two numbers on that number cube that I could be looking for. And that is out of 6 total numbers on the number cube. Well, in my directions, remember I need to write my fraction in simplest form. I know that 2/6 can be divided by 2, and 2 divided by 2 would be 1, and 6 divided by 2 would be 3. So this would be 1/3. If I converted 1/3 to a decimal, that would be 0.3 repeating or 33.3 repeating percent. So because this one is also between 0 and 50, this event would be unlikely. Now let's find the probability of an even number. When I think about a number cube, I know that there are three even numbers on the number cube. Those are 2, 4, and 6. So there are three even numbers on a number cube out of 6 total numbers. Now I still want to write this as a fraction in simplest form, so I can divide both my numerator and my denominator by 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So the probability of landing on an even number on a number cube is 1/2, or zero point 0.5, which could also be turned into 50%. Since this is exactly 50% or exactly 1/2, then the probability or the likelihood of this happening is as likely as not. For example 2, you're going to spin the spinners shown on your paper. You are going to find the probability of each of these events and write your answer as a fraction in simplest form. So I want everybody to do these problems now. Let's check your answers. Part A says the probability of a 7. When I look at the spinner, I see that there is one 7 on the spinner and there were 8 total spaces. So the probability of landing on a 7 is 1 out of 8. Now let's look for the probability of landing on an odd. I see that there are 1, 2, 3, 4 odd numbers on my spinner, and that's out of 8 total spaces. So the probability of landing on an odd is 4 out of 8. But I know that 4 out of 8 can be simplified to 1/2. Part C says the probability of 1, 2, or 3. Well, when I look on my spinner, I have 3 sections that are 1, 2, or 3 out of 8 total sections. And since that fraction cannot be simplified, that will be my answer. Example 3 says a bag contains 3 blue, 4 red, and 5 yellow marbles. We want to find the probability of each of these events as a fraction in simplest form. Before I can get started, I need to know how many marbles are in the bag. So if I need to know how many marbles are in the bag, then the first thing that I need to do is add what they've given me, which is 3 blue plus 4 red plus 5 yellow. When I do that, I find out that there are 12 total marbles in this bag. Now I want you to find these probabilities and write your answer as fractions in simplest forms. For part A, it says the probability of a red. There are 4 red marbles in our bag, and we know that there are 12 total marbles. So the probability of a red is 4 out of 12. I know that both of these are divisible by 4, so I can divide by 4. And 4 divided by 4 is 1, 12 divided by 4 is 3. So the probability of landing on red is 1/3. Part B says the probability of a yellow. Well, there are 5 yellow marbles in my bag out of 12 total marbles. So my probability is 5 over 12. That cannot be simplified, so my final answer here would be 5/12. And then our last problem says the probability of blue or yellow. Well, when I look at my problem, I know that there are 3 blue and 5 yellow. So since both of those would be acceptable answers, there are 8 total marbles that are either blue or yellow. And that is out of 12 total marbles. I can simplify 8 and 12 because both are divisible by 4. If I do 8 divided by 4, I'm going to get 2. And when I do 12 divided by 4, I'm going to get 3. So the probability of landing on or pulling a blue or yellow marble is 2/3.